In this episode, we are going to focus on the stage where an AI system's behavior is shaped most directly, training and tuning. For brand new learners, it can be tempting to think of training as a one-time event where you feed the system data and it learns. But in real organizations, training and tuning are ongoing activities with many decisions embedded inside them. Those decisions matter for risk because they can change what the system outputs, how it behaves under stress, and what it might leak or amplify. If you cannot reproduce what you did, you cannot prove control, and if you cannot prove control, you cannot manage risk in a disciplined way. That is why the title emphasizes reproducibility, versioning, and provenance discipline. Reproducibility is the ability to get the same result again when you use the same inputs and settings. Versioning is the ability to track what changed and when, and provenance is the ability to trace where data and components came from and whether they were appropriate. Together, these ideas stop AI development from turning into mysterious experimentation that nobody can explain after deployment. By the end, you should be able to describe why training and tuning must be treated like controlled processes, not like creative tinkering. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To make this easier, let's define training and tuning in plain terms without getting lost in math. Training is the process of adjusting a model based on data so it learns patterns, and tuning is any process that adjusts behavior to fit a specific use case, which can include fine-tuning, preference tuning, prompt templates, retrieval settings, or other constraints. The important thing is that both training and tuning change behavior, and behavior changes are risk changes. If an AI system gives advice, then tuning that makes it more confident can increase the risk of unsafe recommendations. If an AI system summarizes sensitive documents, then tuning that makes it more detailed can increase the risk of privacy leakage. Beginners sometimes assume that tuning is only about making outputs better, but better can mean more persuasive and more fluent, which can be dangerous if it is also wrong. Training and tuning also influence fairness, because they can improve performance for some groups while leaving others behind. When you control training and tuning, you are controlling the levers that shape how risk shows up in real outputs. That is why this topic belongs in Domain 3, where lifecycle controls and data discipline protect people and organizations. Reproducibility is the first big idea, and it matters because without it, you cannot separate a real improvement from a lucky accident. Imagine you change something and the system seems better, but you cannot reproduce the result later, and you cannot explain what caused the change. That situation is common when teams move fast and treat training like an art project, but it is dangerous because it creates false confidence. Reproducibility means you can take the same dataset, the same model version, the same settings, and the same process, and produce results that match closely enough to be trusted. You do not need perfect identical outputs for all AI systems, but you do need enough repeatability that you can verify changes and identify causes. Reproducibility also matters for accountability, because when someone asks why the system behaved a certain way, you need a defensible explanation. It matters for auditing, because auditors need evidence that your process is controlled rather than random. Beginners should think of reproducibility as the difference between science and guesswork. If you cannot reproduce, you cannot learn reliably, and you cannot control risk. The reason reproducibility can be hard is that many moving parts influence model behavior, and beginners often underestimate how many. Data changes, pre-processing changes, labeling changes, and environment changes can all shift results even if you think you ran the same training. Tuning changes can also interact in surprising ways, where a small adjustment produces a large behavioral shift. If you are relying on third-party components, those components might update without you noticing, which can break reproducibility. This is where provenance and versioning become essential, because reproducibility requires you to know exactly what inputs and components were used. Another beginner point is that reproducibility is not only about training runs. It is also about being able to recreate the conditions that produced an output, especially when investigating incidents. If you cannot recreate the conditions, you cannot test fixes confidently. The practical outcome is that reproducibility is a control that supports both quality and safety. When teams adopt reproducibility discipline, they reduce the risk of shipping changes they do not understand. Versioning is the second big idea, and it is the way you keep track of change without relying on memory. Versioning means you assign identifiers to important things so you can say, this result came from this specific model, trained on this specific dataset version, with these specific settings, in this specific environment. Beginners sometimes think versioning is just naming files, but in risk management, versioning is how you maintain traceability and prevent confusion. If a user reports a harmful output, you need to know which version produced it, because the fix might be different depending on what changed. If you run tests, you need to tie the test results to the exact version tested, because test results are not meaningful if the system changes afterward. Versioning also supports rollback, which is the ability to revert to a previous safe state if a new version causes harm. Without versioning, rollback becomes risky because you might revert to something you cannot fully identify. Another important point is that versioning should cover not only the model, but also the configuration and the data, because those elements define behavior just as much as the model weights do. When versioning is strong, change becomes manageable and auditable. A key beginner insight is that versioning is also a communication tool across teams, because it gives everyone a shared language. Security teams can say this version introduced a new interface, and we need to assess it. Privacy teams can say this version uses a new dataset, and we need to confirm consent and purpose limits. Product teams can say this version changes user experience, and we need to update guidance and monitoring. Legal teams can say this version changes claims, and we need to ensure messaging remains defensible. Without versioning, people talk past each other because they may be discussing different system states without realizing it. Another benefit is that versioning supports experimentation safely, because you can compare versions and learn what improvements truly worked. That learning is part of continuous improvement, but it must be disciplined to avoid accidental harm. Beginners should remember that change is inevitable, so the question is whether change is controlled. Versioning is the backbone of controlled change. Provenance discipline is the third big idea, and it means you can trace the origin and legitimacy of the data and components that shape the system. Provenance answers questions like, where did this training data come from? What permission do we have to use it? What transformations were applied, and who approved it? It also includes where models and tools came from, such as whether a model was obtained from a trusted source and whether it was modified. Provenance matters for privacy and legal compliance because you need to know whether the data used fits purpose limits and consent. It matters for security because untrusted data or untrusted components can introduce poisoning, backdoors, or hidden dependencies. It matters for quality because unknown transformations can distort meaning and create unexpected behavior. Beginners sometimes think provenance is only a paperwork concern, but it is also a safety concern because unknown origins create unknown risk. If you cannot trace provenance, you cannot confidently defend your system when questions arise. Provenance discipline is therefore a form of risk hygiene that prevents you from building on questionable foundations. A practical way to understand provenance is to think of it as the biography of your training and tuning inputs. When you know the biography, you can evaluate whether the inputs are trustworthy and appropriate for your use case. If the data came from internal support tickets, you need to know whether customers expected that use and whether sensitive information was filtered. If the data came from public sources, you need to know whether it includes copyrighted or toxic content that could shape outputs in harmful ways. If the model came from a vendor, you need to know what training sources and safety methods they used and what limitations exist. Provenance also includes documenting changes, because data can be updated, filtered, or augmented, and those changes can shift what the model learns. Beginners should remember that a model does not learn values from nowhere. It learns from the examples and signals you provide. Provenance tells you what those examples were and whether they were appropriate to teach the system. When provenance is weak, you inherit hidden assumptions that can later surprise you. Now let's connect these three ideas to the life cycle and to real risk outcomes, because the point is not to memorize definitions, but to understand why they prevent harm. If reproducibility is weak, you can accidentally introduce a behavior change that increases hallucinations or unsafe outputs without being able to trace why. If versioning is weak, you can test one system state and deploy another, creating a gap where your evidence no longer matches reality. If provenance is weak, you can train on data that includes sensitive content, biased content, or poison content, and then deploy a system that leaks or discriminates. These failures are not rare because AI work involves many moving parts and rapid iteration. That is why discipline is needed, not because teams are careless, but because complexity creates risk. Beginners should see these controls as guardrails that make innovation safer, not as obstacles that slow everything down. A disciplined process can actually speed up work by reducing rework and incident recovery. Control makes progress sustainable. It is also important to address a common misconception, that the goal of tuning is simply to make the system more helpful and more natural. Helpfulness is valuable, but in risk management, helpfulness must be balanced with safety, privacy, and reliability. A tuned system that is more persuasive can be more dangerous if it is also wrong, especially for new users who trust it. A tuned system that is more detailed can reveal sensitive content if controls are weak. A tuned system that is more eager to act can create security risk if it triggers actions without oversight. That is why tuning must include explicit constraints and testing that reflect what the organization considers unacceptable. Another misconception is that tuning is reversible without effort, when in reality behavior changes can be subtle and hard to unwind if you do not have strong versioning. This is why controlled tuning includes keeping records of what you tried and what effects occurred. Beginners should remember that tuning is a risk lever, and you should treat it with the same care you treat access control or incident readiness. Finally, controlling training and tuning means building habits that support ongoing oversight, because AI systems are rarely static. As new data arrives, as user behavior changes, and as threats evolve, teams will want to update and improve. The discipline you build now makes future updates safer because you can reproduce results, track versions, and defend data provenance. It also supports monitoring and incident response because when something goes wrong, you can identify the version, recreate conditions, and test a fix with confidence. This is what it means to be able to prove control over time rather than hoping the system stays stable. For beginners, it helps to think of the system as a moving target that you are steering, not a machine you built once and walked away from. Reproducibility keeps your steering accurate. Versioning tells you where you are on the path, and provenance ensures you are using safe fuel. When those three are strong, you can improve the system responsibly without losing track of what changed. As we close, controlling training and tuning is about turning AI development into a disciplined, explainable process rather than an opaque experiment. Reproducibility ensures you can trust your improvements and investigate failures. Versioning ensures you can track what changed and connect evidence to reality, and provenance discipline ensures you can defend the origins and legitimacy of the data and components that shape behavior. These controls reduce risk across privacy, security, fairness, and reliability because they prevent hidden changes and unknown inputs from driving outcomes. They also support lifecycle governance because they create artifacts that prove you manage change responsibly. For brand new learners, the key takeaway is that AI behavior does not simply happen. It is created by choices, and those choices must be traceable. When you can explain why reproducibility, versioning, and provenance matter, you are ready to understand how organizations keep AI systems under control as they evolve and as the real world pushes back.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.